We shall see. Okay, Lace? Is that okay, Lacey? Thanks. It means a lot coming from you, dear. That's just really cool. I know I'm happy. It's exciting. Where did we leave off here? Yes, trig limits. Here's a couple of sort of fun ones that are, well, easy. So you can say like the limit as x approaches pi over 2 of the sine of x. Well, duh, it's 1. How do I know this? A little review from last time. Because sine is a, starts with a C, continuous function. And because it's continuous, I know that what? The limit is the value at that function, yes? Yeah, I remember that, Mr. Grew. Yeah. Then you're like, well, wait, that would be true for cosine too, I suppose. You're not wrong. Well, just a cotton flopping minute.
Well, it's the whole.
The limit, of course, as the tangent as x approaches, pi over 2 is going to be an ithue. But why is that? Because at pi over 2 it's undefined. It is not continuous at pi over 2. Right? Right. This one is just special for Lil. Lil. What about this feller? Oh. Ah. Hey, look, on top it's undefined. Oh my gosh, it's undefined on the bottom too. So quickly now, what is undefined divided by undefined? So help me God, if anybody writes 1 on this, I will puke. I will literally projectile vomit on you. That is disturbing. Later on, we're going to see something like this. And if you write 1, I will literally vomit all over you. Now listen, friends, the limit may end up coming out to be 1 in a minute, but the actual value is unfreaking defined. Son of a gun, does that say Bakersfield High School? Is that where you came from?
Yeah.
That's pretty exciting. One of my best friends in college was from Bakersfield. He was a pretty cool dude. Yeah. It's a very nice place. I mean, I guess.
Come on, man. Where's that?
Yeah. About an hour or so north of LA. Hour and a half-ish.
Right now it's like dirty because of wildfires and all that.
Yeah.
It's pretty interesting.
Nice. Well, good. Well, exciting. So, let me tell you this. What is the tangent, friends? Last I checked, the tangent was who over what? What is it now? Sine over cosine?
Yes.
Ew. And what is the secant? 1 over?
1 over
Cosine. Which, of course, translates into this dealio. Sine over cosine. That is cosine over 1. So the limit as x approaches pi over 2 of sine of x is 1. Hallie, let me say it again. Undefined divided by undefined does not equal 1. Even though Mrs. What's-her-schnutz actually told you back in the day anything divided by itself is 1. Well, anything except 0 or things like undefined. That doesn't work either. Okay, but the limit happens to be 1. That is a nice little algebraic function there, is it not? It's kind of cute. It's nice. I dig it. All right, Brooklyn, this next one's all yours, okay? Are you with me on this, Brooke? It's pretty exciting. I'm kind of excited. No, this one is all you, girl. I know you can do it. I have faith in you.
Okay, we'll see.
Girl, that's stupid. I don't know what I'm doing. No, you do. You do. It's fine. So I was gonna say tangent, but I want to say the limit. There we go. The limit. Uh-oh. Uh-oh. Check us out, dog. On the bottom. What do you notice there, kid? What do you notice? 1. Uh-oh. The cosine of 0 is 0, Mr. Groom. Or is 1. 1 squared is 1. 1 minus 1 is? Oh, no. And on top it's also 0. Oh, no. This does not equal 1. Please do not do that. It falls under rule number 1. Don't piss Mr. Groom off. So, as Zach was pointing out, the bottom can be redefined as sine squared. Yes? You need to be good at that. And then, of course, that really is just 1 over sine x, yes? So then I have the limit as x approaches infinity, or 0 rather, of 1 over sine. What is the sine of 0?
0.
It is 0. So 1 over 0, oh, weird. That can't happen. So we say the limit is undefined. Now in a minute we're going to go look at the graph of this thing. What do we know is happening at 0? We know what the graph's going to look like. What's going to show up at 0?
Either a hole or an asymptote.
No, not either or. It's one of them. And it's what? It's an asymptote. If it was a hole, when I simplified it, what should have happened? It should have cleaned up, just like this one did. See how that's pretty? This one all of a sudden is fixed. Yes, I fixed the hole. That's what goes in the hole. This one is, that's not fixable. Sorry, this is, you ran your finger through the meat grinder. It's not fixable. Skill saw, yes. Meat grinder, not so much. Sorry, you have to learn how to just pick your nose with the other finger. Okay? So, yeah, it's gross. Now, I thought you were going to ask a question. You were giving one of these, though, so good for you. No, it's fine. So, I thought you were going to ask a question. I was getting ready to be, like, just wowed and everything, but apparently not. So, we'll just go this route. Let's go actually take a look at the graph. Now, remember, you're not going to be graphing these, so don't get in the habit of, like, oh, I'm going to graph everything, Mr. Grum. No. But we will be doing a few things. Oops. Remember when you type these in, they must be 1 cosine x, like so, squared. Hey, look what happens at the 0, friends. It is what? Clearly an asymptote, yes? And if you graph, and by the way, isn't that just a graph of secant, Mr. Groom? I feel like you're not wrong. Oh, or can't I just graph cosecant, I mean? Probs. Oh my God, they're all the same. I know. That's the whole point. Okay? It's beautiful. But wait, Lacey, you say, let's look at the previous page. I said, okay, fine. On this one over here, it was, let's look at him, shall we? So tangent x divided by secant x. Wow. Hey, check it out. Boom. That pi over 2. Right. Give it to me. Pi over 2 is 1. Yay. Now, this is sad, by the way. This is kind of sad. What did you expect to see there? Kind of is expecting to see a hole, weren't you? This is a deal where sometimes those computer programming nerds forget things. That should be a hole right there, right? Now, obviously, when it reduces to sine, and so it wouldn't have a hole if you reduced it, but it should theoretically have a hole right there. That's a problem. But again, not an asymptote. Not an asymptote. Now, so here's a fun question for you. What is, all those ones we've just been doing are easily reducible. What if you run into this beast in a dark alley? By the way, what's the only value of x that's going to cause us an FU?
Oh.
Can you reduce this guy at all?
No, that's not how it works.
Just killed a couple of kittens with that comment. Awesome.
Wait, sine of 0 is 0, right?
It is.
So that'd just be 0 over 0.
Which is?
0, yeah.
Which is undefined. Hey, what does it look like it ought to be?
That's weird.
It really looks like it ought to be what? It is undefined, but what does it look like it ought to be?
1.
It is 1. not close to 1, the limit is, in fact, 1. Period. Exclamation point. Oh, wait a minute. Wait. I have a question though, Mr. Green. Because what if, I mean, I feel like you messed up, Mr. Green. Because what if it was like 6 sine x over x? What would you do? I'd pull that out front of it as me. That would call me weird, but that's what I'd do. And I'd get 6 times the limit as x approaches 0 of sine x over x, which is 1 times 6, which is 6. Yay! Okay? This is one you need to memorize. Now, there's about 2 of them, Lacey. That one and one other one. They're not very difficult. They are not very difficult. That one is pretty easy to do. Later on, we'll prove to you why they are the way they are. But for right now, you're just like, oh, that's cute. I can memorize that. But later on, we'll be talking about why it is that way. Now, in chapter 3, anyways. Now, there's this one here as well. And again, the limit as x approaches what? I feel like we should probably graph this one and see what it is before I just say, hey, that is the answer. Because I feel like... Oh, look at that. What does it look like it ought to be?
0.
Sure looks like it ought to be 0. But it's, of course, undefined there because it's a not continuous function. And that's another one that we're going to memorize. Later on, again, we'll prove to you why they must be the way they are, but that's what they are. Nice. So, here are some problems similar to that you will see on your homework today, and you'll be like, oh, this is really easy to do. For instance, I'm going to die. So, I don't know, you might see this one. Don't cry if you do, it's pretty easy to do. 34, which is number 34 in your homework. The limit as x approaches 0 of the tangent of 4x over 9x. What do you notice about them? Well, I feel like if it was cosine or sine, if it was sine on top, I'd know what to do, wouldn't you? Right? Because sine x over x, we just did that a few minutes ago, or something like that, right? And that would be cool. So, but how am I going to get sine out of this mess? What is tangent? It's sine of x, in this case sine of 4x, over cosine of 4x, all over 9, right? That's what it is, really, right? Which, of course, you could, if you wanted to, rewrite as something like that. Oops, 9x. Sorry, I knew it was there. Which you could rewrite if you wanted to. Now, what do you think about this? Just tell me what you think about it. Don't cry, because I'm right. But tell me what you think about it. That bothers you, doesn't it? Why? Whatever's on, listen, first of all, maybe I could have included an extra step here. Let me include an extra step. That make you happier? That make it more betterish? Because remember, when you have a fraction, you divide it by a whole number, the whole number just ends up in the denominator, yes? If you don't believe me, ask yourself this question. We have a third of a pie. There's 4 people coming to dinner. What do each of us get? We each get 1 over 3 times 4, 1/12 of the pie, yes? Right? Right? Right. Which isn't much pie, so make some more pie, okay, when I come over? Okay, I don't want to share. So are you good to hear this part? Yes? We good? Now can I add? Okay, so here's a question for you. So, Mr. Green, wait, why'd you do this? Because I'm weird? But remember, the limit as x approaches anything of f of x times g of x is equal to the limit as x approaches c of f of x times the limit as x approaches c of g of x. Does it not? I feel like it does. So what I'm saying is I was taking the limit of that. Now I'm taking the limit of these two pieces individually. So I could leave it as written as a product like that, or I could put it back together. I think I'm just going to leave it for right now. I think later on I'll actually blow it into bits, but for right now I'm good. Oops. Okay, now here's a question. If you cannot find the limit of this piece, you might have issues, yes? Because this piece is what? Well, the cosine of 0 is 1. And then times 9 is?
9.
And so it's 1 over 9 is 1/9, yes? So this portion over here, I mean, we're basically done with this piece, yes? That's this piece right here. But this piece here, I don't know what to do about this piece yet. Actually, that's a lie. I know exactly what to do. Don't worry, Mr. Groom didn't get lost. What does this bottom need to be in order for this to be what I want it to be? Doesn't it need to be a 4x down there?
Yes.
Because if you go back to that previous page when I showed you this, I think I wrote it like this over this. And people go, oh, it needs to be x over x. No. X is a very generic way of saying what? The same thing, yes? It can be anything, yes? So listen, I've got 4x on top. Do you see that? Is there anything I can do about having 4x in there? Not easily. Not easy. Although extra credit if you could show me what to do with that. But no, not easily. So what am I going to do? I'll tell you what I'm going to do. I'm going to times the bottom by 4. Okay? Now it's the same number on top and bottom. That's the problem with that though. You can't just times by 4 on the bottom, can you? You better do it on top too, right? Right? Because what if I multiply by? 4 over 4 is 1. Yeah, look at that. Yeah, Olson talked to me. It's exciting. So I can pull the 4 out front if I wanted to. And what is this limit here? The sine of anything over itself is what? Is 1. Times 1/9 times 4 is, so the answer is 4/9. And we are just going to be rearranging and doing some goofy things like that today as we go along. And I think you'll find them to be, well, not hard. Messy sometimes? Maybe. Tricky-dicky sometimes? Maybe. More likely if you're just, you're not really into it, or you're texting or face paging and doing all this other stuff at the same time, you may have issues. If your mind's not into it. If you're vaguely into it, you should find it to be not hard, I don't think anyways. You also may run into this beast today, or one akin to it. Hey, what's up with this one? Well, our tools are this guy, we've seen this guy, and we've seen this guy. Right? It vaguely looks like this one, yes? Could I make it look like that more? How? Do it, Garth. Right. And since we know the product of the limit is the limit of the products. Right, I think that's what I said. But whatever, you know what I meant. Okay, well, what is this? Sine of t over t is 1. And times the sine of, what is the sine of 0, friends? It is 0. So the limit will be 0. But again, it does not exist at 0. We'll just have a limit at 0. By the way, it's actually kind of cool. Because the sine function is always less than 1, yes? What happens when you square a number that's less than 1? Well, it gets smaller is what I was going for, yes? If it's a fraction, you square it, it gets smaller. So what's going to happen is that because it was this earlier was just sine of t over t, they were getting going towards 0 at the same rate. Now they're going to be getting, this top's going to be getting smaller faster, and it's going to be going to 0 on that problem, which actually kind of makes a lot of sense later on. How about this one, and then we'll play some games here in a jiffy, I think. Well, not some games. We'll do some different things with it, I should say. That's boring. That's totally boring. Literally, that's horribly boring. How about this one? Lame. Oh, here we go. Loving it. Now what, Hannah Morse? Well, you never told us on the square root in it before. Oh my gosh! No, I'm just teasing. Go ahead. What do you got? What do you think? Okay. Can I ask? I have a question. Here's the thing. Just tell me what you think, okay? No one is going to judge you. And listen, if you're not been wrong before, it's high time you started. Okay, it's get used to it, because you're gonna make boo-boos. Just say it, kid. I got faith in you. That is a fabulous idea. I don't think that's what I would do. It's not a bad idea. Not necessarily wrong. I don't think that's where I'd go with it. What about you, Connor? Knowing what the limit laws are and all. Hey, look at that, like Brooklyn's going back and checking out. I feel like we did something like this a minute ago, sort of, kind of. It's not wrong. Keep going. I'm watching for you. Go ahead. No, I know, I'm waiting. Back in the day. Oh. That's right, I am. Tell anybody. What were you going to do, Brooklyn? You tell us then. You probably were right, by the way. Do it.
What do you want to? Okay, so the limit as t approaches 0 of the square root, and then and sine t, and then the limit of t as t equals 0 of t equals, and then you would just like keep.
Were you going to say times here? Is that what you're saying?
Wait.
Is this what you're saying? I guess I kind of got lost.
It might be the wrong.
Is this what you were saying?
Like I'm saying, put like.
Is that literally what you were saying? That's right. But why would she do it like this? Why would she do it like this? Because we know this piece, yes? And what is the limit of that piece? 1. And then I like what you're saying. Mr. Grimm, can we just pass that limit inside? You're right, we could. So, I mean, you could do this. I don't think I need to anymore, but I could, because I feel like you're pretty smart in that regard. Right? Hey, what's the limit as t approaches 0 of 9? I feel like it's 9. Hey, what's the limit as t goes to 0? It's, well, it's 0. 0 cubed is 0. Plus 9 is 9. Square root of 9 is? And 3 times 1 is 3. If you are ever in doubt, you're like, I checked the back of the book, but I feel like their answer might be wrong, but I'm not sure. Oh, you hippie. What a person could always do is check the graph. Didn't say graph it right off the bat, and if you cannot do these algebraically, you're not going to pass the next test, so figure it out. And we said at x equals 0, yes? Well, x equals 0, what does it look like? Feel like it's awfully close to, pretty close to 3, isn't it? Nice. Which is good, because that's what it's supposed to. What's happening out here? Who freaking cares? Who cares what's happening out here? By the way, what can you say about the function right here? What is it kind of a function? Is it right here? It's continuous right here, yes? So if you want to know the answer to this question at x equals whatever I'm on, 7.02, you would literally drop 7.02 into there and get an answer out, wouldn't you? Boom. The only place this function's interesting is at 0. It's the only place it's very strange and interesting and does weird things. is right there. Everywhere else, it's a pussycat. I want to know what the answer is at 16. Oh, well, plug it in. Plug it in. And by the way, pretty exciting. It just keeps getting bigger and bigger and bigger. I could watch that all day. You're right. I'm kind of a boring person. All right. How about this one right? Ooh, I'm going to fool somebody. Who am I going to fool? Yeah, I'm going to go up, though. Nice. All right, what are you going to do, man?
Well, I feel like
Well, now I'm going to have it going. So what do you want to feel like? I don't
you could, well,
I feel
I feel
like
like you can get a sine over sine out of there.
a sine over sine. How?
Well, you know, I'm seeing sine squared on the bottom, and you shouldn't have that on the bottom.
What do you want to have?
We should get rid of the sine
Ooh.
squared. So I'm trying
Check
to
it out.
think about how
He's
to
assuming. Okay, good. Yeah, so I don't know if that's the right thing. So, but I like what you're saying. So somehow we've got to get a what? Something over. We got to get that sine to be over 3t, don't we? I mean, that's kind of what we need to have happening, right? But there's two of them down there, isn't it? That's going to be weird, dog. I don't know what we're going to do about that. Now, of course, the things we can do are multiply top and bottom by the same thing. Yes? Right? So, I mean, I think it'd be really easy to do is to make this be over. Now, well, here, I'm going to do this. Is this okay for everyone? I'm just going to rewrite it as that, yes? Because that's what sine squared is. So what would go right here? 3t and 3t, right? That would fix that, yes? But if I did it there, I better also do it where? Up on top too. So I'm going to write that 9t squared if that's okay with you, okay? So now what do I have? Now I have this mess. And I'm not sure I'm any happier than I was a minute ago, but maybe I am, I don't know. So on top I've now got this mess. Now on the bottom I've got this mess. Right? I guess that makes me a little happier. Because I know that this is the same as this. Is the limit as, t approaches 0 of the numerator divided by the limit as t approaches 0 of sine of 3t over 3t times the limit as t approaches 0 of the sine of 3t over 3t. But listen, we're done on the bottom, aren't we? What's the bottom? It's 1. That's handy. The only thing I don't know is what I'm going to do with that top mess. That's disturbing. Right? It's just gross. So what I end up now with is I end up with this limit of this mess. Okay? That's gross. That looks vaguely familiar, doesn't it? Doesn't this bit here look vaguely familiar, sort of? Doesn't it look an awful lot like this? Doesn't it? But what would need to be down here in the bottom of that thing? Well, first of all, I need to have a 1 or a 2 in front of this number down here, right? I mean, I need to beat it to look like this thing. We're going to beat it into submission here. So my first thought is, what can I do with this 9 in the basement? What can I do with it? It's just a constant, isn't it? So couldn't I pull it out front and write 1/9 times the limit?
Yes.
as, and then I'm going to have 1 minus cosine of 2t Everyone okay with that? In other words, I'm going to break it into two pieces. Yes? No? Maybe so? Now what is it? What do we need to put right here? A 2. But you just can't stick a 2 and not do something else, so where are you going to put the other one? Up here? Maybe? Or if you prefer, out front. Makes no difference to me where you put it, but it better be on top somewhere. So now we're going to say it's 2/9 times the limit of this thing times the limit. It's t. Oops, t better approach something, I guess, huh? It's t. Go away. Well, this is 1. What's the limit of 1 over t as t goes to 0? I feel like that's undefined. Uh-oh. So it feels like we should have an undefined statement going on, which means that when I look at the graph in a minute, prob's going to be an asymptote floating around. Okay? Now, let's go look at the original function. The original function was what? 1 minus cosine? Brooke, was it 1 minus cosine? Is that right?
What, you want the original one?
Yes.
1 minus cosine
2x divided by?
divided by sine of 3t.
Oh, well, first of all, it's sine
Or so sine, yeah, the very original is sine squared.
of 3
Yeah,
x.
yeah,
What? Hey, that's always it's squared though, right?
yeah, squared.
Yeah, that's pretty nasty and sick. Look what's happening at 0 though. What do we have? The asymptote. It's the asymptote, isn't it? Which is why, when we do it algebraically over here, that is why we got an undefined. Nice. Okay, so you're going to be doing some of those today on your homeworks. You need more time with that? Okay. But notice all we did was use the limit laws. That's all we're doing. Well, and things like whatever you do to the top, you do to the bottom. Multiplying by 1. Things of this nature. That's it. That's all. Yeah. Oh, goodness sakes, I'm tired. Okay, that cool? That cool? All right, now this next one, Hallie, it's gonna blow your mind. Here's your mind. This piece of brain coming this way, and some going up. It's a mess. This next one is going to be. Oh no! It's gonna be a mess. So you probably should put a little drop cloth down. It's gonna get ugly. Suppose you had this guy right here. No! Now, if you were a betting man, what would I want x to go to? I mean, 0 would work, but it'd be really easy. Just throw 0 in, Mr. Grimm. That's really stupid. The only place where this graph is interesting is where? 3. And why is that? Because that's going to give you a 0 in the denominator right here. Oh, look, it's going to be 0 times 0 divided by 0. Oh. Now remember, for God's sakes, this is undefined. Do not write 1. Now the limit in a minute very well may be 1. The limit might be. But if you write 0 equals 0, my equals 1, I swear I'm taking 1,000,000 points off a 5-point problem. I swear I am. Don't even do that to me. That's gross. Now, what do you notice here, friends? You know what we need? We should look at the graph of this beast. Now wait, I feel like, what does this guy look like to me? I feel like when x is greater than 3, this is positive on top, yes? This guy on the bottom is always positive, yes? So that'd be positive 1, yes? So this minus this over this, when this is true, will be equal to 1, positive 1. What happens when it's less than? No, you don't. You just get a negative. And a negative what, particularly? -1, right? That make sense? So wait a minute. I know what x squared minus 9 looks like, right? You do too. I know you do. You people are smart. Smarter than I am. It's not even funny. So look, what does x squared minus 9 look like? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3. It looks like this graph right here, yes? Right? But what's going to happen when when x is greater than 3, this number here just becomes 1, yes? So anything out here, is it going to affect the graph at all? It's going to be the same blessed graph out here, isn't it? Right? Does that make sense? Because this piece here will be equal to 1 when x is, for instance, like 4. So this graph, x squared minus 9, is just going to stay x squared minus 9. But if you put x equals 0 in there, this also becomes, but it becomes -1. So instead of being down here at -9, it's going to jump up here and be at +9, isn't it? And what we're going to see is we're going to see some kind of a bendy deal in the middle of this thing doing its thing. I don't know what it's doing. Actually, that's not true. I know it's going to do something like this. Okay? Now we're going to graph this in a second. But what I want to know is, what does the limit look like on this function? And to that, we're going to use a cool new thing you've never seen before. It is one of the cooler things in mathematics. Cool, yes. Easy, yeah, more or less. Totally easy to understand. Totally easy to understand. Like, oh my gosh, that's the easiest thing ever to understand. Do you see the graph? Do you see it? Do you see it? Do you see it? Do you see it? Can you see it's exactly what I said it was going to be, kind of? Huh? Okay. No, what's the matter? What's the matter? Do you see it? Do you want me to graph x squared minus 9 all by itself? What? Right? Now again, when x is less than 3, this x minus 3 over absolute value is -1. So all these values that are negative are going to become positive, yes? That's this hump up here is talking about. And then, ooh, but these guys are positive, Mr. Groom. Good. So times them by a -1 and you get the green line extending down this direction. Okay? Now, here comes the fun part. What I'd like to do is I would like to see if I could do something with this thing. Now, can I simplify this algebraically? Not really. Not really. What I could do is this. I mean, I guess you could say this if you wanted to, Lil. It's this if x is bigger than 1, or not 1, 3 rather, sorry. And you could say it's equal to this if x is less than 3. And that's great, but that doesn't help me about what happens at 3. Okay, I don't know. Because remember, it's undefined at 3, yes? Because it becomes 0 over 0. So I need a way to figure out what it is. And the way we're going to do that is what is called the squeeze theorem. Was that the outside? The squeeze theorem. And here's the deal. Given a function, I don't know, I'm going to use g of x. You need to select two functions, f of x and h of x, such that, now this is a big deal, f of x is always less than or equal to g of x, and h of x is always greater than g of x for all x. In the neighborhood of the x value in question. So in our case, around x equals 3. Okay? Now, it doesn't say it has to be that way always, just in the neighborhood. Now, here's the dealio. Back in the day, someone told you that whatever you do to one side, you must do the other side, yes? But check this out. Suppose I take the limit as x approaches a of f of x. Well, I'd have to do it in here, wouldn't I? Right? Right? Here's the thing, Garth. These two functions up here, there's an also f, the limit as x approaches a of f of x must equal the limit as x approaches a of h of x. Wait a minute. If this guy equals this guy, if the two outside guys have the same limit, what does that say about the middle one? It also must share the same limit. Okay, that's it. That's all there is to this thing. Right. Right. Now back to the graph. What function would fit nicely into this little v right here? What function would fit nicely into there? Well, it's got that V shape, so. Ooh. I feel like it doesn't fit inside the V. How am I going to make it fit, inside the V?
X equals 3.
Well, no. Ooh, that's close. Oh, hey, that's nice. Mr. Grimm, is there a right way and a wrong way to go about this one? No. No, that'll be dandy right there, won't it? So, for instance, one of ours could be 15 absolute value x minus 3. Because it is greater than x squared minus 9, x minus 3, absolute value x minus 3. You see that? Now, what is a function that is less than it? Oops. What's a function that's less than that green line? Well, some of us would say y equals 0. Well, you're not wrong. In the neighborhood, it is less than the green line. Less than or equal to, yes? Does it have the same limit as the orange one? Yes. Because the orange one, what happens as you approach 3, the orange guy is headed towards 0, isn't it? This one's 0 always, so that would work. Other people go, Mr. Grimm, I'm going to use the same exact function again because I'm lazy. Which is fine. I'm not judging, just saying. Oh, that's nice. Oh. But again, no real right or wrong answer. There's wrong answers, but there's not really one exact right answer. And so if I take the limit of this side, as x approaches 3, of negative 15 x minus 3, like so, I see that is 0. Get the limit on the inside, which I have no idea what it is. Which is also 0. So what does that say? It says that this limit is equal to 0 because I pinched it between two functions with known limits. Known limits. Now, interestingly enough, some people, for instance, maybe, I don't know. I feel like Lil might do this. Lil might go, 10. But if she zoomed out a ways, she might think that blue function is inside the green function. Of course, she's ridiculously wrong. It's disturbingly wrong how wrong she is. Because it clearly is not. You see what I'm saying? It's not okay. Frequently, what's going to happen on these functions, frequently you're going to have this v look to them. That's why we have an issue with them, honestly. And so frequently it's going to be an absolute value function. And remember, absolute value of x is simply right here. Ooh, I need to scoot him. Why are they both green? That was just plain weird. Can you change the colors? Where? Oh. Nice. Right on. Anyway, I need to squish it. So obviously that's just a times it by something. Well, that's nice. Oh, I gotta move it. Ta-da! I need to reflect it over. Good, make it negative. Whatever. But Mr. Kim, I don't want to be so big on the bottom. Good, then don't. Voila. Any of them will work, friends. You just need two functions that share the same limit at that value. Continuous functions are best, although no one said they had to be continuous. For instance, if you're weird, you're like, Mr. Grimm, could I do the same thing with sine of x over x? Why, yes, you could. If I hadn't have told you what this looked like, and you said, Mr. Grimm, I'm going to graph. So I come along here and I go, you know, sine of x. What is a function that is less than that guy? I feel like 1 minus x squared is less than that fella, yes? And I also feel like 1 minus 0.001 x squared. Ah, what happened? Go away. Yeah, is like bigger than him everywhere. But at 0, they share the same limit, which happens to be 1. And so the blue line, this purple line, is between them. Ergo, the limit is 1 for him as well. Okay? Again, there is wrong ways to do it, but there's lots of right ways.